Hello class, this is the second installment of our videos regarding hydrates and combustion analysis. In fact, this video is only about combustion analysis. Now, be careful. Sometimes the combustion analysis problems are worded in such a way that it makes things a little complicated. Here's what I mean. Sometimes an element is determined via a separate experiment. So you will have one problem, but you have two separate experiments. This makes things a little more complicated. However, there is a very, very simple solution, and that is using percentages. Let's work from an example. Let's say we have this problem here. Scary, huh? All right, let's get to it. First, we get the grams of each element. There, you have it. I hope there is no surprises there. Hydrogen, look at that 2 written in blue. Do you know why? You got it. The number of moles of hydrogen is equal to the number of moles, twice the number of moles of water. And then oxygen, we leave this for now. We leave this on the side for now. Chlorine, the problem gives us 22.06 grams in 75 grams in a 75 gram sample. So what we do is we determine the percent composition. So the carbon over 40 is so 15.985 grams over 40.10. This is the percentage of carbon in the sample. Hydrogen, likewise. Chlorine. Notice that we are using data from the other experiment. And then oxygen, we said we were going to leave it for later, right? So here we do it now. So we subtract as usual. And now we have percentages for each element. Now, do you think we can use percentages to determine a formula? You bet. We know how to do that. That's how we did empirical formulas. Okay. So we proceed as we did with the percent compositions, and the answer should be that. Okay. Now here is a second example. Again, a very scary problem, but it's just a paper tiger. Okay, scary but doesn't bite, doesn't even bark. Now you may be wondering why that 7-Up picture there. Well, here is the answer. The answer is there was some blank space there, and I just needed to fill it with a picture. So I just grabbed a random picture. So don't worry about that 7-Up. If you don't like 7-Up, don't just skip to the next slide. And if you love 7-Up, there you have it. So again, we are used to this. We go ahead and determine the percentage of carbon in the sample, determine the percentage of hydrogen in the sample, determine the percentage of sulfur in the sample. Again, if you don't know how to do this, make sure you ask in class. Okay. Now, again, oxygen, how do we get it? By subtraction. And once we get all these percentages, we proceed like we know how to, and we get to the final answer. All right. Learning check. This is, we are going to be doing this in class. And, but if you want, you could give this particular problem a shot. Okay, if you would like to give this problem a shot, go ahead and pause the video because I'm going to be giving you the answer. So I don't want to spoil it for you. Okay, so feel free to pause the video. But here is the answer, and the rest of the problems we'll be doing them in class. And this is the end of this video, and this is the end of our work on percent compositions, empirical formulas, molecular formulas, hydrates, and combustion analysis. I hope you enjoyed it. I hope it was useful. I will see you in class.